Good morning.
Good morning, sir.
Okay. Today we can deal with the topic braking of the vehicle on a curved path. So, on a curved path or while taking a curved path, what are the braking forces or the forces dealing with the vehicle? We can see. So, braking on a curved path. Vehicle on curved path. Okay. So here you will see a figure. Suppose this is a vehicle and this is one wheel. Okay. Let this be the front portion and this is the rear portion. Rear portion. Okay. And this vehicle is moving in a curved path like this. Curved path. So if this vehicle is moving in a curved path, we know that any body moving in a curved path or a circular motion, undergoing circular motion, is experiencing a centrifugal force, right? So, and this centrifugal force will be acting radially outwards. So, in the case of this vehicle, let this point, let some point here. This be the center of gravity. Center of gravity. Then the centrifugal force will be acting radially outwards. Let this be the center point, or this is the radius of curvature of the curved path. And so the centrifugal force, let it be denoted by Fc. That will be acting through the center of gravity radially outwards. Okay. Now we know that we have learned many cases, mainly 3 cases for braking. Or in the first case, we considered when the body is braked, or when the rear wheel or the brake is applied to rear wheel only. And the second case, the brake applied to front wheel, and the third case both wheels are braked, or the brake is applied to both the wheels. Okay. Anyway, in any case, any of the case, we know that there will be a frictional force acting in the opposite direction, of motion of the body. So if the rear wheels or the braking is applied to the rear wheels, then the brake force will be acting in the opposite direction of motion. That is, it will be in this particular direction in the case of rear wheels. And we can denote it as FR. And in the case of front wheel, if the brake is applied to the front wheel, then the body is moving in this particular direction. So the friction will be in the opposite direction, and it is in this particular direction in the both case, or the both wheels in the same direction, and it we can denote it as F. F. Now we know that while moving in a circular path like this, what happens is there will be a centrifugal force which is denoted by Fc, and due to the centrifugal force, the body may have a tendency to move in the radially outward direction. So in order to prevent that, by the surface, due to the surface properties like friction, mainly by friction, it opposes the radially outward direction, right? So in order to oppose the radially outward direction, it may create a friction in the opposite direction, or a force, side force. It is determined as side force, and the side force will be acting in the opposite direction. So at the point here in the front portion, let it be denoted by capital P. So we can notate the side forces on each wheels here. Denoted by capital P. Then side force at the rear portion, capital Q. Capital Q. Okay. So these are the forces. So the forces acting on the vehicle are, first of all, we know that any body undergoing circular motion will be experienced by a centrifugal force which is acting radially outwards. Here it is denoted by Fc. Now, due to the centrifugal force, in order to oppose the centrifugal motion or the radially outward motion, the what do you say? Surface creates the opposite force, that is side force. The side force is denoted by capital P for the front wheels, and for the back wheels or the rear wheels it is denoted by Q, which is opposite to the direction of the centrifugal force, and this is acting like this. Now let us consider capital W W, the weight of the vehicle, in newtons. Then capital C by the radius of curved path, that means this particular radius. This is capital C. Now V denotes the velocity of the all particles of the vehicle. Velocity in meter per second. This is in meter. Okay. Now P and Q be the side forces. P, Q are the side forces. Then FF and FR. FF and FR is denotes the braking forces. Okay. So now we know that the centrifugal force FC we can denote as FC equal to centrifugal force, we know mv square by r, right? The relation mv square by r. Instead of m, we can write w by g into v square by r. Instead of r, we are using c. So this much Newton. This is the center of relation for the centrifugal force. And here we have to see one thing, that is, in this case where the vehicle is moving in a circular motion or in a curved path, actually the braking capacity of the vehicle is decreased, because the in the case where it is moving in the straight line, there the full amount of the braking or the power we are giving to or applying while braking will be utilized for creating or FR and FF. But here a part of the friction force will be distributed for the side force also. So there are two components in the friction, that is FR and Q, or at the tire surface there are two types of or two components of the friction will be acting. So friction, first case, that is and the main friction force, that is braking forces FF and FR. FF and FR are responsible to decelerate the vehicle. So using this force, braking forces, the vehicle is stopping or decreasing its speed. But what happens is, in this case, a part of that will be consumed by the other force, that is the side force. So the resultant will be acting as the force. So as a result, there will be a decrease in the force, or we have to or the capacity, braking capacity is decreased. This will be more clear while we do one problem. So I think you have a notebook with you. So please keep ready with your notebook. നോട്ട്ബുക്ക് ഒക്കെ എടുത്ത് വെച്ചോ കയ്യില്? ഒരു ക്വസ്റ്റ്യൻ ഉണ്ട്. പ്രോബ്ലം സിമ്പിൾ പ്രോബ്ലം ഹെഡിങ് ഉണ്ട് അതിനകത്ത് സിലബസില്. ഇതുവരെ ചോദിച്ചിട്ടില്ല. അതുകൊണ്ട് ഒരു ഒറ്റ പ്രോബ്ലം മാത്രം നമുക്ക് ടെക്സ്റ്റിൽ പറയുന്നുണ്ട്. അപ്പൊ ആ പ്രോബ്ലം ജസ്റ്റ് ഒന്ന് നോക്കി പോവാം. എങ്ങാനും കഷ്ടകാലത്തിന് വന്നു കഴിഞ്ഞാൽ ഉപകരിക്കും. വലിയ പാടൊന്നുമില്ല, ജസ്റ്റ് ഇക്വേഷൻ ഉണ്ട്, അത് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യാം, ദാറ്റ്സ് ഓൾ. ഓക്കെ. Okay, done. Question. A motorcycle has a wheelbase of 1.5 meter apart. Okay, wheelbase. Wheelbase എന്ന് പറഞ്ഞാൽ എന്താണ്? Distance between the two wheels, അല്ലേ? ഫ്രണ്ടും ബാക്കും തമ്മിലുള്ള ഡിസ്റ്റൻസ്, അതായത് തന്നേക്കുന്നത് b equal to 1.5 meter. Okay. ഇനി പറഞ്ഞത് എന്താണ്? Center of gravity of the cycle and the rider is 0.7 meter above the ground level. അപ്പോൾ ഗ്രൗണ്ടിൽ നിന്ന് സെന്റർ ഓഫ് ഗ്രാവിറ്റി വരെയുള്ള ഡിസ്റ്റൻസ്, അതിനാണ് നമ്മൾ h എന്ന് പറയുന്നത്, അല്ലെ? അതായത് തന്നേക്കുന്നത് h equal to 0.7 meter. 0.7 meter. Then point above the ground level and 0.6 meter in front of the rear axle. That means let this be the rear wheel, and here is the front wheel, and this portion is the center of gravity. Then we know that this particular length, full length, is denoted by d, and this distance, this particular distance, we denote it as L, right? അങ്ങനെയല്ലേ നമ്മൾ ചെയ്ത് കഴിഞ്ഞ പ്രാവശ്യം? അതെ. So here the center of gravity is at a distance 0.7, that is this distance h is 0.7 meter, and 0.6 meter in front of the rear axle. Rear axle in 0.6 meter, അതായത് L equal to 0.6 meter. Then the coefficient of friction between the tires and the road is 0.75. That is mu equal to 0.75. Then if the rear wheel is applied brake, find the greatest deceleration that can be obtained in these two cases. ഒരു p ഏ ഉള്ളൂ. ഓക്കെ, അപ്പൊ ഇത് എന്ത് കേസ് ആണിത്? ഇത് റെയർ വീലിന് ബ്രേക്ക് അപ്ലൈ ചെയ്യുമ്പോൾ ഉള്ള കേസ് ആണ്. അപ്പൊ നമുക്ക് ആ ഇക്വേഷൻസ് ഒന്ന് നോക്കാം. റെയർ വീലിന്റെ കേസിൽ ഉണ്ടായിരുന്ന ഇക്വേഷൻസ്, ബ്രേക്സ് അപ്ലൈഡ് ടു റെയർ വീൽസ്, എന്തൊക്കെയായിരുന്നു ഇക്വേഷൻസ്? കേസ് where the rear wheels are applied brake, in that case എന്തായിരുന്നു? നമുക്ക് കുറെ റിലേഷൻസ് ഉണ്ടായിരുന്നു. RR RF അതിന്റെ ഒക്കെ റിലേഷൻ ഉണ്ടായിരുന്നു. RR എന്ന് പറഞ്ഞാൽ എന്തായിരുന്നു? RR which will be equal to B minus L into cos theta into divided by B plus mu H into W. അതേപോലെ RF equal to L plus mu H into cos theta divided by B plus mu H into W. And the relation for F by G, was mu into B minus L into cos theta by B plus mu H whole minus sin theta. Okay. Also, there are certain relations when sigma fx equal to 0, sigma fy equal to 0, and while considering sigma m equal to 0, also we got some relations. Anyway, these are the main relations. So here we consider a general case where the plane is inclined at an angle theta. So in this question, it is moving in a level rod. So theta equal to 0, and so we can write we can use the relations where theta equal to 0, cos theta becomes 1. Here also 1. So RR equal to B minus L by B plus mu H into W. RF will be equal to L plus mu H by B plus mu H into W. And in this case, the sin theta will be 0, and the equation will be like this. Okay. So now the first question is, if the motor is moving in a straight path, so it is moving in a straight path. Straight path means there is only one component of friction, that is the braking force is there. And in that case, what is the greatest deceleration? Deceleration is denoted by F. F. So we know this relation for in the case where the brake is applied to only rear surface or the rear wheel. Here F by G will be equal to mu minus BL cos theta by this much. But in this case, we are taking theta as 0. So we can write F by G equal to B minus L mu into B minus L by B plus mu H. Okay. So here we can substitute the values. Mu is 0.75 into B minus L, that is 1.5, minus L is 0.6 divided by B 1.5 plus mu 0.75 into H 0.7, and we get the value around 0.33. So now we know F by G equal to 0.33, and G is the we know the value of G as 9.81. So we will get the value for F as, this implies F equal to G into 0.33, that is 9.81 into 0.33, and you will get a value approximately 3.237, this much meter per second square. So this is the maximum deceleration when the body is the body is moving in a straight path. Now the second case is if it is going around a curved path of radius 46 meters. If it is moving in a circular path, what all will be the deceleration. So in that case, we know there are two components for the friction, that is friction force, the side force. There will be a side force and also the frictional force. So the resultant will be like that, like side force will be acting, braking force will be there, it will be like this, braking force. So this is the side one. Side force, side force, and this is the brake force, brake force. So the resultant, this is the resultant force, which will be represented by mu r, mu r. Okay. So we'll see the second case, case 2, case 2. That is the body moving in a circular path, right? Body moving in circular path or curved path, curved path of radius, radius 46 meter, and the here they are given the radius as 46 meter and velocity 50 kilometer per hour. That means radius given by c, that is 46 meter, and velocity as 50 kilometer per hour. 50 kilometer per hour, or 50 into 1000 by 360. Sorry, 1000 by 3600. That much meter per second. Okay, so the centrifugal force in this case, the centrifugal force can be denoted by centrifugal force Fc will be equal to W by G into V square by C, right? Now we don't know the value of W, so we keep the W as such and substitute the rest of the values. So W by 9.81 into V is 1000 by 3600. We can denote as 50 divided by this value is we can write 3.6, that is 1000 by 3600 we convert it as 1 by 3.6 and denoted like this. V square by C. C is 46. 46. Okay. So from here we get the value after simplifying. We get the value as 0.427 W. So this much Newton will be the centrifugal force. This is the total centrifugal force acting on the body. Now this is the body, and this is the front and rear portion. This is the center of gravity. We know the distance from rear to this particular center of gravity denoted by L, and the total length is denoted by B. So if the center of the centrifugal force, total centrifugal force Fc is acting like this, then we can say it is assumed to be shared by the two wheels, that is the rear portion and also the front portion, in a particular manner. And by the geometry we can say that this be the rear portion, this is the front portion, and this is the center of gravity. So here it is the L, this particular length is L. So the centrifugal force here, the centrifugal force shared by the rear wheel, that is this portion, will be equal to this particular length, that is B minus L in by total length, that is B into the centrifugal force. This will be the part of the centrifugal force which is shared by the rear wheel. Now the part of centrifugal force shared in this portion will be just opposite line. This, that is the distance, this particular distance divided by the total distance into Fc, that is this distance is L, so L divided by total distance B into Fc. So this is how the centrifugal force is shared by the two portion of the wheels. So the total centrifugal force is denoted by Fc, whose value is 0.427 W. This will be shared by the front and rear portion like this. So so the centrifugal force shared by, we can write centrifugal force shared by rear wheels. Rear wheels will be equal to B minus L by B into the centrifugal force, that is 0.427 W. Okay. So on substituting the values and simplifying, we get 0.256 W. And similarly for the front wheels, that is centrifugal force shared by front wheel. Front wheel will be L by D into the centrifugal force, that is 0.427 W, and you will get, on simplifying, you will get a value that is 0.170 W. Okay, so I think we can wind up this section now. We will continue in the next class. Okay.